Hello, everybody. Uh, I welcome you very pleasantly to my presentation about miniaturized camera systems for endoscopy. I'm René, the CEO of Feinwerkoptik Zünd AG, and I'm very happy to give this presentation at the booth of Synex Consulting Limited at the KIMES 2024 in South Korea. So before I'm going to start with my presentation, I would like to just explain the location we see here, the beautiful scenery with the castle of Württemberg, our company here, and this quite nice apple tree in front of the even nicer mountains of the Alps. And we are located in the triangle of Switzerland, Austria, and the Principle of Liechtenstein. I would like to structure my presentation accordingly. First, I will talk a little bit about Feinwerkoptik Zünd AG, also known as FWAS. Then I continue to market study for endoscopy, trends in endoscopy, and miniaturized camera systems, especially for laparoscopy, robotic surgery, and intraoral cameras. We have been established in 1991. The company was founded by my father. He's still with the company, but with a very little pension. And yeah, but we are still happy that he's around. We are a leader in miniaturized optic systems, and that includes photonic concepts, systems design, and production. So these three pillars are very crucial and build the basis of our doings and our capabilities. We are 30 people in Württemberg. Württemberg, as I already mentioned, is a small town in the east part of Switzerland, in this triangle, Germany, Austria, and Principle of Liechtenstein, but France and Italy are neither quite far apart. So we are very close to all these 5 countries. Our key production capabilities are spherical optics, planar optics, and systems assembly. These 3 divisions are very roughly explained with these keywords, but what I would like to highlight definitely is the sizes of the spherical components, for example, we produce, and the size ranges between 0.35 millimeters and 8 millimeters. The quantity we produce are a few hundred or a few thousands in pieces. So 500 to 10,000, for example, could be very typical for our production capabilities. We are mostly active in the markets medical, industrial. Medical is definitely endoscopy, for example, and industrial is more laser applications, for example. The growth rate of our company is about 20%, and we could keep up the pace after pandemic. During pandemic, it was a little bit slower, of course. So here we see quite an informative slide with the first line we see here explains or represents achromats, shaped windows, objective lenses, light mixing rods. So the first 3 items are representing spherical optics, and the last one is representing planar optics. That's just one example of light mixing rods. There are, of course, many different opportunities we can provide. It's also only an example of these spherical components. So the variety is huge. Please keep in mind that miniaturization is key for us. So the components we have on this first line and the assembly systems we have on the line below. So we see here the intraoral camera as an example, which I get back to later, and also a stereo objective lens, which I get back to later. The fields we are active in is here explained with the medical division, and the medical division includes mostly endoscopy, surgical robots, dental, and also ophthalmology. So the biggest fields we are active at are, I would say, the first two, and the bottom two are also existing, but not in this not in this deepness as the other two. Now I would like to talk a little bit about the market study for endoscopy. We analyzed the market, especially in the US, because there is also the very active region regarding startups of surgical robots, but also other very innovative company, as you may know, the Silicon Valley, which is definitely representing this area very enormously. So what we see here is a division of rigid endoscopes, robot-assisted endoscopes, and some others, for example, flexible endoscopes. The rigid endoscopes and the robot-assisted endoscopes are our highlighting activities. All the others, for example, the disposable endoscopes, we don't touch. So neither the capsule endoscopes you swallow, for example, to inspect and to image the stomach. The market size is gonna reach 28 billion by 2030, and the growth rate is about 9%. Within this 28 billion, we expect the laparoscopic share of 16 billion by 2030. And that's all only considered and analyzed by the American market. So there is nothing more than the American market, because we had quite trustful numbers for this market. But it is quite a big market, and we would like to be a part of this market. The trends in endoscopy are obvious, at least in our view of perspective, and we highlight here on this slide at least three, and these are miniaturization. We don't need to talk about what it means, because it's so obvious. Everything wants to go smaller. We want to go even more minimally invasive, and we want to make the incisions into the human bodies even smaller. So that's a very obvious trend we have recognized all over the years. The second trend is high resolution. As you know, the pixel sizes of all the digital cameras are getting smaller and smaller. That means we can bring more pixels on the same area size, and that means one driver is also high resolution. Either we speak from opportunities in the distal end of the endoscope, that's in the tip of the endoscope, or at the proximal end, which is located at the handle of the endoscope. 3D endoscopy and surgical robots are close together because it's somehow related. So if we talk about 3D endoscopy, of course you can proceed 3D endoscopy also without a surgical robot, but it is very much needed, and it is crucial for surgical robots that you have a 3D endoscope introduced. Otherwise, you can't navigate. It's very hard to navigate because one dimension is missing. And last but not least, there is a macro mode endoscopy from Olympus, for example, and we try to step into this field as well. So that's only an example of and a little bit a teaser what we are working on, but that you get to know the trends. It's also covered with that keyword. So now I would like to switch to the three examples I prepared for this presentation, and that's the miniaturized camera system for laparoscopy. And what we see here is a quite complex chip-in-tip objective lenses, and chip-in-tip means that all what you see here is at the distal end of the endoscope. So that means the whole endoscope is, in this case, divided into two parts. the distal ends with the chip-in-tip objective or camera system, and the rest of the endoscope. We see here the cover or the protective window. Then we have the first lenses which represent a negative lens. Then we have a cylindrical lens with a plano-convex lens, and so on. So we have different lenses introduced into this objective, and at the final lens, that's here, that's the sensor. And in this case, it's a full HD resolution sensor, and it's, you see it here, full HD means 1920 by 1080 pixel. The outer diameter of the chip and tip camera has got 5.2 millimeters, so that's the part here, the widest part of the chip and tip objective lenses. We have a f number of 5.4, and the spectral bandwidth we have optimized for this miniaturized camera systems ranges from the visible to the NIR spectral, so it's 850 nanometers is covered. The application is laparoscopy, as we see it also in the title or in the signature above. That means we provide here a solution for laparoscopy, which asks for somehow high resolution, but at the same time in a moderate diameter of the dimension. So that's very important that we don't exceed a certain diameter, and 5.2 is somehow the maximum. We are positive that we can go below 5 millimeters, but at the moment it's 5.2. The next example I want to explain here is a miniaturized camera system for robotic surgery. It's a very similar system to the objective we saw before, because it's also for laparoscopy, but we have two channels. So that means two channels are located next to each other, similar as the human eye, that we can see three-dimensional. And that's one of the key properties at robotic surgery, that you are able to perform a perfect optical image on the screen to provide best 3D impression for the surgeon. And what we have here are two identical lens barrels next to each other. Each of them have got a resolution of full HD, and the outer diameter both together, so you can think of a circular shape including two lens barrels, is 12 millimeters. We have again f number 5.4, and again the spectral bandwidth. That's very typical at the moment to perform also fluorescence applications at robotic surgery. And very important, as I mentioned, it provides stereoscopic vision. Last but not least, we have this intraoral camera, which is a very interesting product because we have also introduced a liquid lens. So what we see here is the complete system without sensor. That's what we don't see here. And you see it already according to the ingredients of this intraoral camera, that there are many, many lenses introduced. And it was needed because we have full HD resolution, a very long image translation chain without rod lenses, and that asked us to be very creative in finding the solution. And this liquid lens, which I mentioned just before, is very interesting because we can zoom in to a very tiny region of the tooth, for example, to observe the nerve of the tooth, and we can zoom out to create a picture of the whole face, and we don't need to change the device. It includes also fluorescence application and other features which I can't explain in detail at the moment. So that's actually what we provide for you for the South Korean market. And we would really be happy to get in touch with you, that you can learn more about these miniaturized cameras and about all what we can customize for you and for your customers. Please get in touch over all these channels I highlighted here, LinkedIn, via email, via phone, whatever you prefer. And I'm looking forward to speak to you soon. Thank you very much, and I wish you have a great show at Synex Consulting Limited and at KIMES 2024. Enjoy. Bye.